So, Mr. Strauss's Chemistry Corner is filmed before a live studio audience. No laugh track has been used at all, and no animals were harmed during this videotaping.
Yeah.
So, and to our Polish friends, once again, cześć.
Why are you like this?
And to our German friends, guten Tag. All right. I've got quite a following in Poland, believe it or not.
No, you don't.
So, one goes here, three goes there. Okay, but I do have some people in Alaska. That's for real. Crisscross, right? For a single displacement reaction. Erase the one, erase the charges. The magnesium is all by itself, okay? It's not an ion. Now that I've balanced these individually, now I'm going to balance the whole reaction using coefficients.
Is it not on your good side?
Pretty much.
You have no good side.
Whoa.
Shots fired.
Where did that come from?
All right. So the method of balancing is called guess and check. Literally guess and then check. You want to use a pencil. Pencil's your friend. I start with magnesium. There's one magnesium here. How many are over here? One. So I'm happy. Two chlorines over here. How many over here? Three. Not balanced. So what do? Just erase this and write a 3? No, you can't do that.
That's what I'm doing.
You got to balance using coefficients. So I put numbers out front, and the lowest common multiple of 2 and 3 is 6. So I'm going to put a 3 here, and what that 3 means is I'm basically distributing it, just like you would in math. So 3 times 2 is 6. I put a 2 here. 2 times 3 is 6. But what does that do to my magnesiums now? Now I've got 3. So I'm going to have to put a 3 there. Aluminum, 2. And again, you switch the two metals or the two nonmetals. Because if we have this one, sodium fluoride reacting with chlorine, sodium is Na, plus 1 charge, fluorine is minus 1. I balance it. What's the formula for chlorine? Is that it? When chlorine's by itself, it must be binary, diatomic. So that's why we memorized those magic 7. Hydrogen, nitrogen, oxygen, and then the halogens. So when I switch, when I do my single displacement, I'm going to be switching the two nonmetals. So it's either the two metals or the two nonmetals. And when I switch, I don't bring the subscripts over, I just switch the symbols. So I end up with Na, Cl, write the charges, and I end up with fluorine. Can fluorine be by itself?
No.
Yet. So we put a 2 there. Erase the charges, and now when we balance, use coefficients, Leia. So in order to get two fluorines, I'm gonna have to put a 2 there. In order to get two fluorines, do I just put a 2 there? No. We gotta balance using coefficients. So that gives me 2 sodiums, 2 chlorines, and I have 2 sodiums over here and 2 chlorines. Okay.
So
Is
then
that
the
good,
two is
Igor?
The 2 is distributed to the fluorine as well.
The 2 is distributed to the fluorine as well. It's just like in math.
Or need
Gotcha.
parentheses?
No, you don't need parentheses, not in chemistry, but I'm just saying it's like math that is distributed to both things. So that's single displacement. Double displacement, you have 2 things switch. So for double displacement, let's do this one. Oh, let's not do that one. Let's do double displacement reaction. Let's do iron 3 chloride plus calcium phosphide, sure. So, what's the charge on iron?
3.
3, because the Roman numerals tell us it's 3. Chlorine is -1, because we memorized that from the columns. We end up with that, iron chloride. Calcium is in the +2 column, phosphide's in the -3 column. So you end up with a 3 there and a 2 there. So that's what we're gonna balance now, iron chloride reacting with calcium phosphide. The reason why it's called a double displacement malversata is because the calcium is going to displace the iron, and then the iron is going to displace the calcium. A double switch, if you will. VJ. Double switch. So, switch the symbols, not the subscripts. So when I switch the symbols, I get calcium bonding to the chlorine and the iron bonding to the phosphorus. I did not bring the subscripts over. You have to rebalance it, Cassidy. So, charges. Phosphorus is -3. Now what about the iron?
It's also good.
Iron can be a 3 or iron can be a 2. So how do I know which one to do?
Look at the beginning of the equation.
Lucky for you, you can pick any one you want. Either one, it doesn't matter. Okay, you can pick either charge. However, your life will be easier if you pick the same charge as it was on this side. They're just easier to balance. So if you pick the same charge, it will be easier to balance. So that's balanced, that's balanced. Now we balance using coefficients. So I've got 2 here and 3 here. That's toughy. So I'm not going to do that one. I'm going to start with my iron. 1 iron, 1 iron. Phew, that's easier. 3 calciums. How many I have over here? 1, so I need a 3. And that's why this is called guess and check. All right. What does that do to my chlorines now? 3 times 2 is 6, so I'm gonna need a 2 there. 2 times 3 is 6. What does that do to my iron? Now I've got 2 irons, so I'm gonna need a 2 there,
You have 2 P's over there, so it's fine.
2 P's over there, and it's fine. Now what happens if, for whatever reason, no matter what you do, it's not balancing?
Cry.
Well, sometimes you do. So what if I'm like, oh, now I need a 4 over here. And now that I put a 4 there, I need a 6 there. Now that I got a 6 there, I need a 7 there. Now that I got a 7 there, I need an 8 there. And now I need a 4 there, and a 3 there, and a 2 there. And what if it never balances? It means stop. You did something wrong. Go back and check each individual formula. Okay?
This in
So-
integrated science.
What?
We did this in integrated
Yeah,
science.
some of you have done this in integrated science. We're taking it to the next level, and that you're gonna have to predict the products. Okay? Because they should have had this, they gave you the products in integrated science. And some of you haven't taken integrated science. Okay, let's do then, let's do one more example of that one. Let's do a little bit tougher one. Let's do calcium fluoride plus aluminum carbonate. So calcium fluoride plus aluminum carbonate. So the formula, it's an ite. Everything on the periodic table wants 3 oxygens. Those are 8s. Okay, if it has what it wants, you change the N to 8. If it's ite, it means it's got 1 less. So instead of being FO3, it's FO2. It's got 1 less oxygen. The charge is the same as its column. 1 goes here, 2 goes there. We're going to react it with aluminum carbonate. Aluminum's 3 plus. The charge on carbonate is 2 minus. You can look that up on Appendix A, or you can remember bacon, right? Borates are -3, carbonates are -2, nitrates are -1. So either you memorize it or you look it up on Appendix A. Crisscross, 2 goes there, 3 goes there. I erase my charges. So when you switch, Cameron, you either switch the 2 metals or you switch the 2 non-metals. Okay, it doesn't matter which ones you switch. When you switch the symbols, not the subscripts. However, you never change what's inside the parentheses. So when I'm switching, so the aluminum's going here, the calcium's going there. So when I switch, I don't change what's inside the parentheses. I don't bring that subscript over. That one does not come over, but the one inside the parentheses does. I rebalance it. Same thing with the aluminum. It's now bonded with the fluoride. I don't bring that subscript over, but I don't change what's inside the parentheses. So So I get that. I erase my charges. And then I balance the whole reaction using coefficients. So usually, again, it's just guess and check. So 1 calcium, 1 calcium. 2 aluminums. I put a 2 there, I get 2 aluminums. How many fluorates do I have, or how many fluorines do I have? You take the outer number times the inner number. So 2 times 1 is 2 fluorines.
Right.
How many do I have over here? 3 times 1 is 1, but then I have a 2 out here. So 3 times 1 times 2 is 6. So I'm going to need 6 fluorines. So I'm going to put a 3 here, because now 2 times 1 is 2, times 3 is 6. So the number of fluorines is now the same. But what does that do to my calciums? I've got 3, so now I'm going to have to put a 3 there. How many carbons do I have? 3 times 1 is 3. 3 times 1 is 3. And then the last thing we have to check is the oxygens. I recommend leaving oxygen to last. What's 2 times 2? 4. Times 3 is 12. So there are 12 oxygens there. What's 3 times 3? 9. What's 3 times 3? 9. 3 times 2 is 6. Times 2 is 12. So does the number of oxygens balance? Yes. Okay. Now as you get good at this, you can balance the whole cation. Anion, sorry, the whole anion. So I could look at this and say, how many carbonates do I have? Don't balance the carbon and the oxygen individually. How many of those do I have? 3. So how many of these should I have? 3. Then what does that do to my calcium? I got 3. How many fluorites do I have? 2 there, times 3 is 6. So I'm going to have 6 fluorites over here. So I'm going to need a 2 there to give me the 6 fluorites. So you could balance it that way too, as a group. Okay? One more type and then we'll do our demo. Okay? Actually, we're going to skip type 3 synthesis. We're going to go to type 4 because it's more fun. Combustion. So the first type of reaction is when you react with oxygen. Anytime you react with oxygen, that's combustion. There are 2 types of combustion. Organic. And type B, inorganic. We're just going to stay with organic for today. Organic is when you've got carbon, hydrogen, or oxygen or nitrogen, essentially. So I'm going to take sugar and I'm going to combust it, meaning react with oxygen. So anytime you react with oxygen, it's combustion. If it's organic, meaning reacting with carbon, hydrogen, or oxygen, you're always going to get two products out. The same two products produces CO2 and water. So anytime you combust an organic, you always get the same two products.
You always get one.
CO2 and water. You always get those two products. So basically, we're skipping the first step here. You don't need to switch the symbols. You don't need to balance it. We know what the products are. So we can go straight to balancing the whole thing with coefficients. And a good recommendation is leave elements till the end. So balance the compounds first, leave the element till the end. So how many carbons do I have here? 6, so I'm going to need a 6 there to give me 6 carbons. How many hydrogens do I have? 12, so I'm going to need a 6 there to give me the 12. How many oxygens do I have now? 6 times 2 is 12,
18.
plus 6 over here is 18. How many do I have over here? 6 plus 2.
Balance the element.
If I put a 6 there, that would give me 12 oxygens. So 6 plus 12, that does balance. So it usually works out better, Eli, if you weight and balance the element at the end, as opposed to doing it from the beginning. I mean, it can work any way, but it just is easier if you do this. So what I've got here is a little